As we perform different kind of operations on different kind of numbers in our daily life, but before solving any problems that involve number operations, we should be aware of the properties of that number. And our today's lecture is all about the properties of real numbers. First of all, let me tell you that the real numbers has 5 multiplication laws, 5 addition laws, and 1 distributive law. And we will first describe the addition laws and then we will move towards others. So let's start with addition laws. The very first addition law is colloidal property of addition or colloidal law of addition. What this property says? This property says if we have two real numbers a and b, and if we add these two real numbers, then we should get the third number that should also be the member of real set. This is the expression of first law. For all, this symbol represents for all a and b members of the real number, and we add a and b, then we should get the third number that should also be the member of real numbers. So this is the property of colloidal law of addition. Now let's take some example to verify this law. Let we have two real numbers a and b. A is equal to root 2 and b is equal to 3. We know the decimal representation of root 2 is 1.414 and so on. It's non-terminating and non-recurring. But here, just for checking purpose, just to understand, I write in a short way. So let's add these two numbers a plus b. After the addition, we will get 4.42. So we need to check either 4.42 is present in the set of real numbers or not. So the answer is yes, it is present. We can draw this number on the number line. So this is the real number. So this means that real numbers satisfy colloidal law of addition. Now the second law is associative law of addition. Basically this property says, in a simple words I can describe this in this way. If we add three real numbers in any order, we will get the same result. Means order doesn't matter. This is the expression for all a, b and c are the members of real numbers, and if we add b plus c first or a plus b first, we will get the same result. These two equations are equal. Okay, let's check. Let we have three real numbers. A is equal to 2, b is equal to minus 6 and c is equal to 1 by 2. Its decimal representation is 0.5. Now we need to check if we add b plus c first and then add b plus c into a. So is it same if we add a plus b first and then add a plus b into c? So let's check. This is the calculation of this side, a plus into b plus c. So the result of this side is equal to minus 3.5. Now we will check the second side, and the result of this side when we add a plus b first and then add c into a plus b, the result of this side is also minus 3.5. So we can see both sides are equal. So this means that real numbers also satisfy associative law of addition. Now the third law is additive identity, and that is the interesting law. Basically additive identity means if we add actual number of any set into the additive identity of that set, then we will get the actual number back, as additive identity does not change the actual number. So we need to check it with the set of real numbers. Is there any number present in the set of real numbers that could not change the actual number after addition? So let's think about this. So the answer is yes, there is a number, and that is 0. Means if we add 0 in any number, in any other real number, then we will get back the actual number, as 0 does not change the actual number. So this is the expression of additive identity. For all, a is the member of R, and this symbol represents there exists. So this means that 0 is also be the member of R. 0 also exists in the real set, such that if we add a into 0 or 0 into a, then we will get back the same number, that is a. So let we have a real number minus 5 by 8. Now we will add 0 into the minus 5 by 8, and check either we will get the same result back or not. So minus 5 by 8 plus 0 we know is equal to minus 5 by 8. So this means if we add 0 into minus 5 by 8 or minus 5 by 8 into 0, we will get our number back. So this is the additive identity. In the real set, there is a number that after addition doesn't change the actual number. So this is additive identity. Now let's move towards the additive inverse. Additive inverse is if we add the actual number and its additive inverse, we always get 0. So for real numbers, we need to check either the additive inverse of every number is present in the real set or not. For example, let we have a real number a. So either its additive inverse minus a is present or not. So this property, additive inverse law, says that its additive inverse minus a should be present in the real numbers. So let's check with some example. Let we have a real number minus 5. Now we want to check either 5, that is its additive inverse, is present in the set of real numbers or not. So the answer is yes, 5 is present in the set of real numbers. So when we add actual number and its additive inverse, then we should get the 0. So minus 5 plus 5 is equal to 0. This means that real numbers also satisfy the additive inverse law. Now one more thing to note, that you can see when we add the additive inverse and actual number of any set of real number, then we will get the additive identity of the real set. Whenever we will add an actual number and its additive inverse of real numbers, then we will get the additive identity of real set. So this is all about additive inverse. Now we will talk about commutative law of addition. So what is commutative law of addition? Basically, this law says if we add a into b or b into a, the result would be same, means order does not matter. This is the expression for commutative law of addition for all a and b, both of the members of real numbers, and if we add a into b or b into a, we will get the same result, means these two expressions are equal. So let's check with some real numbers. Let we have two real numbers a and b. A is equal to 6, b is equal to 4. So first we will solve left hand side of equation and then we will solve right side of equation. First we will add 6 plus 4 in this order. We will get the result 10. This is the result of a plus b. Now we will solve right hand side of equation. Now b plus a is equal to 4 plus 6, that is also equal to 10. So this means for the set of real numbers, this expression, this property is true. So we can say that set of real numbers satisfies the commutative law of addition. This is all about addition laws of real numbers. Thank you.